Learners, in this program, we would discuss about the physical features found in the volcanic terrain with special reference to Deccan traps, particularly topographic features, associated landforms, and megascopic features found in the volcanic rocks.
Now, I will discuss about the physical features. Physical features are also very interesting. Variety of physical features are visible in this terrain. See here, this is also a panoramic view of the Mahabaleshwar region or in the western part of the Deccan area, where scientists believe that the eruption that created Deccan traps was associated with the deep mantle plume. And you see, you have number of lava flows, and each lava flow erupted in phases after a periodic interval, maybe few years, 1 year, 10 years, 100 years, 1000 years. So, this kind of mechanism that has taken place, and you see there are grey colored boundaries here. These are the lava flows, and in between lava flows there are ash beds. What I am saying is based on physical evidence that after eruption, the ash which was blown up with the eruption of lava flows later on settle down and form a thin layer, and it looks like a greyish white layer, and you can count, because of these ash beds you can count number of phases of volcanic activity in this area. So, what are the features, physical features that we see in this terrain? There are lava fields, miles together you see lava fields, they are vast, miles together, tens of kilometers, hundreds of kilometers, only one singular monotonous outcrop, that is black colored rock, is visible. But here these rocks, they display lot of vesicles. Why these vesicles are there? Because after the eruption of lava, the lava contains lot of gases and volatiles. These gases, they used to escape out of these lavas, and because of escape of these gases, the open spaces are left behind in the form of vesicles. Here you see not only vesicles, but there are lava channels, lava tubules or vesicular tubules, they are there. Here you see in one of my picture here, vesicular cylindrical tube is there. But why this tube has formed? This tube is formed because of the escape of volatiles through these channels, and the lava flow, it propagates in a particular direction, particularly it follows the slopes, and this forms a toe like structure, toe and heel like structure, just like our toe and heel. So, these toes are also there, you can see here these certain toes, and this indicates the lava flow propagation direction. And later on these toes or lava flows, sometimes they also have vesicles in the central part. You see lava body or the magma which is cooling, after some time you have upper crust which is consolidated, but inside that crust you have hot molten magma. This magma further protrudes in a smaller lobe. So, one after another lobe, the lava propagates in this direction, in a particular direction, particularly it follows the topographic slope. Here the lava pillow, lava sometimes they display interesting morphology which is very much similar to pillow. We call it as pillow lavas, they look like pillow. So, pillow lavas are there. They also have a small carbonaceous material. You may ask where from these carbonaceous material have come. Suddenly the lava flow has come and it has covered the entire topography, and that topography was holding lot of forest. That forest underwent sudden burial or it has burnt down, but their roots they later on carbonized in the form of black carbonaceous matter, which is seen here in this picture. See here, important thing, I have already told you the entire activity that has taken place in phases after a certain time gap. Time gap is always there. It is not hypothetical, but it is evidenced by the presence of paleosols. Paleosols means ancient soils. After the formation of lava flow, the surface is in the interaction of hydrosphere, atmosphere, and as a result the soil profile is developed, and these soil profiles, they hold lot of vegetation. This vegetation later on burnt by the subsequent lava flow, but this soil profile later on fossilized, which is known as bowl beds, bowl B-O-L-E, bowl beds or bowl horizons. They are important horizons, they signify time gap between the two successive lava flows. Lava eruption that has taken place during the Deccan volcanism, it has got certain activity center. There are centers where you find maximum activity, and maximum activity is identified by a differentiation process or fractionation process. What is that fractionation process? Fractionation is like a crude oil. If crude oil is heated and allow it to cool, what will happen? It will split into different fractions, gasoline, kerosene, and left out is the asphalt. Similar mechanism has taken place in case of volcanic rocks here. The rocks which underwent fractionation, they split into different fractions. The earlier fractions, we call it as primitive lavas. Primitive lavas means they have inherent character of the mantle, but later on these lavas, they fractionated into different fractions, and as a consequence they show acidic character, because silica crystallizes in the late phase of the crystallization of basaltic magma. So, this is one of the area in the Deccan terrain, particularly in Gujarat area, which is identified as a major volcanic center here, and this is in the Osham area in Gujarat, where lot of vesicles are coming out, and this rock is not basalt rock. This is not a basalt, but it is a rhyolite, or it is called obsidian, which is acidic igneous rock. So, this rock we have found here, and on the basis of this rock we identify, we call it as a major differentiation center here. And see here how these rocks are there. The pitch stone is pitch like black in color, and it looks like asphalt, and the rhyolite is a name of rock, its color is very much similar to the sand color or sandstone color, and this rock is in the form of a thin bands here. This is one type of morphology which is found in Deccan terrain, but there are other important features also which can be identified or which may be fascinating for the people, like ropey lavas. They look like a rope. See here, it is a collection of ropes. Similarly, here the Pahoiho lava or AA type of lava, which is highly vesicular, glassy, and it shows lateral variation, and it is a technical term that we call it as Pahoiho lava or the compound lava flows. The pillow lavas, as I said earlier, they look like pillows, and see inflated lavas. Some of the lava flows, they are so inflated in shape that they look like a inflated lava here. This section you see here, these are all field photographs here, and each lava flow has its certain zonations. Morphologically, you can divide lava flow into different zones. What are those zones? The uppermost zone is the vesicular, topmost zone is vesicular. Why it is vesicular? Because of the escape of gases. But you have a flow top, then successive layer is called upper colundate structure. Colundate is a technical term where you have straight fractures. These fractures are there, but in lower level these fractures are not straight, or they are sometimes club together and form another zone called entablature zone. This is also a technical term, and the lower part of this flow is called lower colundate structure, where again you have fractures, but these fractures are not exactly vertical, but they are inclined in particular direction. So, this zone is called as lower colundate. So, now we can divide the entire lava morphology into 4 important zone. One is uppermost vesicular zone, which is topmost one, the upper colundate zone, entablature zone, and the lower colundate zone. In case of Deccan volcanism, I have stated much about the lava flows. Lava flows are the just like a sheet like structure, and Deccan volcanism, better it is known as flood basalt. Why we call it as flood basalt? Because you can compare this flood basalt mechanism with the flood. In flood season, the water used to cover the entire topography. Similar mechanism that has taken place, the lava was such a magnificent amount that it has covered the pre-existing topography, and entire topography become flattened. In other terms, we call it as flood basalt or flood basalt volcanism. So, in flood basalt volcanism, lava flow is one of the most important unit, but there are other units, other important features are also there, which are better known as dikes. Dikes, they are the igneous bodies, they are cutting across whatever rock they come across. If these dikes they come across lava flow, they will cut across lava flow. If they come across sedimentary rock, they will cut across sedimentary rocks. So, they are basically intrusions, and these intrusions they are cutting across the lava flows or whatever country rock is existing in this area. So, in Deccan volcanic province, this green color area is lava flow covered, but in this lava flow covered area, red colored area is in the form of dikes. These are the intrusions, and the commonmost trend of these intrusions is almost east-west direction, which is comparable to the east-west direction of the Narmada-Son lineament. So, this is also one of the evidences that the Narmada-Son lineament that controlled the dike activity in the Deccan volcanic province. See here, I want to show you some pictures how these dikes they are cutting across various rocks. This black colored portion is a dike, and the light colored portion is a country rock, which may be sedimentary rock, which may be lava flow, or which may be a metamorphic rock. Here again the dike is cutting across the country rock, and when it cut across the country rock, margins of the dike they are glassy. Why they are glassy? Because these lava bodies they come in contact with the chilled margins. So, sudden cooling of lava is also taking place, and most of these boundaries or the border areas of the dike they are covered with volcanic glass. In a field, sometimes it becomes difficult to identify, particularly in Deccan volcanic terrain, which one is dike, which one is lava flow. The most important criteria by which you can identify is the hexagonal joints. Hexagonal joints, they are just pillar like joints. When they are disposed vertically, then it is certain that it is a lava flow. When they are horizontally disposed, then it is certain that they are from the dikes. Here I have shown one picture here, lava flows with hexagonal joints. In case of dike, horizontally disposed hexagonal joints is shown here in this picture, and in case of lava flow, joints are vertically disposed in the field. That is very important character here. There are other important morphological features also in case of in Deccan volcanic terrain. These dikes, sometimes you have a single dike, you have circular dikes, you have ring dikes, and you have multiple dikes. The entire country is traversed by several dikes. That is also one way of propagation of these basaltic magmas. Then dike is cutting across the lava flow. Dike is also in the form of apophysis, it is in the form of tongues. Wherever they find weak zone, the magma or the lava goes into that and later on consolidated in the form of apophysis. The morphological characters, there are variety of morphological characters and variety of technical terms that has been developed by which you can distinguish one lava flow from the another lava flow, such as the glassy, pitch black with metallic sound. Some of the lava flow, when you struck hammer, they give you a metallic sound. Ferric means large size pyroxene crystals with green colored alteration products. Spotted magnetite crystals, plagiopheric means you have clusters of plagioclase, large crystals at one place. So, these are all technical terms, variety of terms, they have been developed as the study on Deccan volcanism has grown. So, this is, I have covered two major important things, one about the introduction and origin of the Deccan volcanism in India. The second one is the physical features and what are the physical features which are commonly associated with the basaltic rocks or the Deccan lavas.
Now let us summarize what we have learned. We briefly learnt about physical features created by volcanic eruption and how the topography of volcanic terrain looks like. Landforms created by possible centers of volcanic eruption and megascopic features in the volcanic rocks on outcrop scale like pillow lava, ropey lava and Pahoe. Thank you very much.